you can see that NaCl is dissociated into the Na plus and Cl minus of ammonia around the lithium plus, and there will be attraction force between the lithium plus and nitrogen having partially negative charge. Lithium, sodium, potassium, zinc, magnesium, calcium, titanium, chromium plus 2 and samarium plus 2. It will undergoes into the reaction and you will get the alkene. Okay, so dianion will accept a proton from the again from the ammonia and resulting in a monoanion system. So dissolving matter reduction process. It is simple reduction by solution of an electron. Solution of an electron. Okay, you think that it is weird. Okay, chemistry is also weird. You think that, but chemistry is a mystery. You have to solve this mystery to understand the chemistry, and I'm here to expose these mysteries. So let's go into this topic, solution of an electron. Remember this thing that when we dissolve the NaCl into the water, and you can see that NaCl is dissociated into the Na plus and Cl minus, okay, into the water, and there will be a sphere of dihydrogen oxide around the sodium. Okay, and giving you the meaning of dihydrogen oxide, it means water molecule. Okay, there will be a sphere of water molecule around the Na plus and also around the chlorine minus. Similarly, in the case of the liquid ammonia, amines, water, when we use such type of solvent for the metal, and when we dissolve the metal into this, and we can see an intense blue color in the case of liquid ammonia. I will explain you how this color here. But first, in the solution, there will be a ionization of the lithium into the lithium plus and electron minus. Okay, electron have minus charge. Okay, so there will be a sphere of ammonia around the lithium plus, and there will be attraction force between the lithium plus and nitrogen having partially negative charge. Similarly, in the case of the electron, in the electron you can see electron is in the cavity. Similarly, in the case of lithium plus, have attraction force between the partially positively charged hydrogen. But in the case of electron, there will be mobility of electron, and this electron can move and can jump from one molecule of the solvent to the another. So it can jump from one sphere to the another sphere, and due to the mobility, the solution have conductivity. More will be the metal concentration, more will be the electron, more will be the mobility, and more will be the conductivity of the solution. Okay, you know very well about that. But why this intense blue color? I have already told you that there is a sphere around the electron, and this is something complex. Okay, and this electron can absorb the energy from the visible region, and you can see an intense blue color. But there will be also bronze or sometimes something gold color when we increase the concentration of metal. Okay, this is all about the introduction part. But what is dissolving matter reduction and what is the application? Okay, I have already told you that we use metals like lithium, sodium, potassium, zinc, magnesium, calcium, titanium, chromium plus 2 and samarium plus 2. We use solvents like amines, liquid ammonia and water for what? For the dissolving of matter. Okay, but what about the substrate? We require substrate for the reduction. Okay, we use organic compounds to reduce by using this process. Okay, but organic compounds require a solvent like they are co-solvent also, and there is a solvent also. They can easily soluble in the liquid ammonia, but very less. So we require a co-solvent like ether tetrahydrofuran. Okay, what is the temperature? Temperature usually is minus 78 degrees Celsius to the or also minus 33 degrees Celsius. Usually we use minus 33 degrees Celsius temperature. Okay, this is all about the introduction part. What is proton source? Okay, we will require also proton source that we will discuss in the mechanism part. But first of all, let's go into the reaction. So the electron in solution have high reducing property and it can reduce the ammonia to the NH2 minus and dihydrogen cat, resulting in a disappearance of the blue color. But remember one thing, that the reaction is very slow and we have enough electron to reduce the another organic compounds. Why this process is slow? So we can reduce all type of organic compounds like the benzene ring or aromatic compounds or double conjugated double bonds, etc. Let's take the example of the carbonyl compound. You can see here that carbonyl compound have C double bond O group, okay, and the electron can attack on the electron deficient side and the pi bond will break and oxygen will get negative charge. All type of process is here, okay, and you will get a radical anion. Okay, this radical anion is very basic and can accept the proton from the proton source like tertiary butyl alcohol or ethanol, all type of proton source, okay. And this radical anion will undergoes into the monoanion. You will get monoanion. So remember one thing, that this monoanion again accept the proton on the basicity by the ammonia or by the alcohol. After this, it will be converted into the alcohol. Okay, you can see in this reaction. Okay, so forget this. If you will get the radical anion in the previous reaction, okay, remember one thing, if there is no proton source available, what happened? If there is no proton source available, you can see that in this reaction you will get Pinacol coupling or Mcmurry coupling. When the proton source is not available, radical anion will undergoes into the Pinacol coupling or Mcmurry coupling. You can see in this reaction that this Pinacol coupling, this reaction is similar. First, you can get the radical anion, and this radical anion will again combine with the another radical anion, and you will get the dianion system in which anion is on the oxygen. Okay, and after the workup, you will get the Pinacol. It is Pinacol coupling reaction, and the reagent is aluminum amalgam, magnesium amalgam, titanium or chromium reagents, and samarium iodide for the Pinacol coupling. Forget this, and you can get the Mcmurry coupling. What happened in Mcmurry coupling? The reagent is something different. Okay, something different. TiCl3 and TiCl4 are the reducing agent, and we should use this something new reducing agent with this reducing agent like lithium, sodium, zinc, magnesium. Zinc copper coupling is something different. You can see that you have first of all aldehyde or ketone compound, and it will undergoes into the reaction and you will get the alkene. Okay, this is Mcmurry coupling. It will not undergoes into the mechanism. Okay, so it is Mcmurry coupling. So the dissolving metal reduction process for the aromatic compounds, it is known as Birch Reduction process. We use the similar condition like alkali metals, liquid ammonia and proton source. Mechanism is simple. You can see here that first of all electron will attack on any of the carbon of benzene and resulting in a radical anion. You can see here this radical anion is very unstable, or you can see it is basic and can accept a proton from the alcohol if it is present. If it is present, remember one thing, okay, and resulting in a radical. This radical quickly accept electron from the solution and resulting in an anion, monoanion system, and this monoanion again accept the proton from the alcohol or ammonia. In the case of ammonia, there will be a slow reaction, and in the case of alcohol, there will be a fast reaction, and you can see cyclohexadiene as a product. So, in the case of benzene, we will get radical anion, and this radical anion will accept an electron proton source from the alcohol. But what happens if proton source is not available? Remember one thing, if proton source is not available, you can see there is also liquid ammonia which is act as a proton source. So this benzene ring have high electron affinity. So it will accept one electron from the solution and resulting in a dianion system. You can see here in this case. Okay, so dianion will accept a proton from the again from the ammonia and resulting in a monoanion system. Okay, not alcohol, because alcohol is not present in the solution. And
This monoanion again accepts the proton from the ammonia and resulting in a simply 1,4 cyclohexadiene. You can see here in the mechanism. So it is simple. When proton source is not available, you will see a simple dianion. Okay, and resulting in a similar product. You can see that NH2 minus is still present in the solution and can accept a proton from the 1,4 cyclohexadiene and resulting in a monoanion system. You can see in the mechanism. Okay, so it can accept a proton and convert it into the ammonia, and this anion will be resonance stabilized and you will get the 1,3 cyclohexadiene. You can see in the mechanism. Why? This NH2 minus accepts the proton from the 1,4 cyclohexadiene and this monoanion will be resonance stabilized and it will be undergoes into the 1,3 cyclohexadiene. And this 1,3 cyclohexadiene will further reduce by Birch reduction you will get an alkene compound, something like cyclohexene. So remember one thing, if proton source is not available, it will NH2 minus can further reduce this 1,4 cyclohexadiene and can isomerize to the 1,3 cyclohexadiene, and this 1,3 cyclohexadiene further reduced under the Birch reduction and converted into the cyclone. So what happens when substituents is present in the case of benzene ring? There are two types of substituents, electron donating group and electron withdrawing groups. And you can see an example of electron donating group and electron withdrawing group. Okay? So let's take an example of electron donating group attached with the benzene ring like anisole in this case. You can see that when anisole, electron donating group is present at the benzene ring, you can see a reduction at the ortho and meta position. Why? Remember one thing, that electron donating group have plus M effect and it will increase the electron density at ortho and para position, but meta have low electron density. So electron will attack on the meta position. So mechanism is simple. You can see here that electron will attack on the meta position and you can first take the radical anion. So this radical anion will accept the proton from the alcohol resulting in another radical. And this radical is at the similarly at meta position and will accept another electron from the solution and resulting in another monoanion. So it is simple, similar mechanism as the benzene. But remember one thing, if electron donating group is present, reduction will occur at the ortho and meta position, and you can see the product and which electron donating group or like ether group is present adjacent to the double bond. It is simple. But what happens when we use hydrolysis as a reaction after this? So you can see that in the case of ether, when we get the product after the acidic condition and hydrolysis, you will get the alcohol. Okay, you will get the alcohol which is attached at the position of double bond adjacent to the double bond. You can see here, and it will tautomerize into the alpha beta or simply beta gamma unsaturated ketone. But under the strong acidic condition, you will get alpha beta unsaturated ketone. Okay, it is simple process of hydrolysis and tautomering. Okay, you can see here that first of all carboxylic acid is present on the benzene ring, and when the electron withdrawing group is present on the benzene ring, the reduction will occur at the ipso and the para position. Ipso and para position. What is ipso position? When the functional group is attached at the benzene ring, you can see here, and at this side, when the reduction is occur at the functional group side and at the position where the functional group is attached, you can see here, this position is known as ipso position, where the functional group is attached, and the para position is also take part in the reduction. So you can see the mechanism is simple. You know that minus M effect is in the case of electron withdrawing group, minus M effect. And due to this, meta position have high electron density and ortho and para have low electron density. So the first of all, the electron will attack on the ipso position. You can simply see in the mechanism, and you will get first radical anion and then you will get the monoanion, and after this you will get the simple product in which electron withdrawing group is present adjacent to the single bond. and after the single bond you can see our double. Two benzene rings attached with one another, and you can see that first of all any of the ring is similar. Okay, so you can see in the mechanism that first ring will reduce and mechanism is similar to the benzene ring. You can see here. So mechanism is simple. First of all radical anion, then after accepting proton, a radical after accepting electron, monoanion, and after accepting proton, resulting in a reduced product. But remember one thing, one ring is reduced, not the both ring. But if we increase the concentration of metal, if we use the excess of metal, we can see both the ring will reduce. You can see in the reaction like that. Okay, so what reaction is occurring in the case of this? You can see that first of all reaction is occur on both the side, both the ring. On both the ring will reduce. Okay, like that. Okay, you can see that first of all radical anion, then after monoanion, and then both the ring will reduce. So what happens in the case of bicyclic system if substituents is present in the bicyclic system? When electron donating group is present in one ring, the side ring will reduce. Why? Electron donating group give the electron density to the one ring, so the ring having electron donating group cannot reduce. Side ring will reduce. And in the case of electron withdrawing group, it will attract the electron from the ring and so there will be a deficiency at this ring. So the electron will attack on this ring where the electron withdrawing group is attached. And you can see that electron withdrawing group attached at the ring will reduce in the case of bicyclic system.